let's continue. Except networking. You can't build modern software without networking, but the internet makes everything hard. Is it because networking has essential complexity? Well, maybe. But maybe it's only complex when you built it on top of the wrong assumptions. That results in the wrong problem that you then have to paper over. That's the old internet. Alright. So they're saying basically let's look at internet from another perspective, and maybe if we look at it from another perspective, maybe there's a new solution which is pretty scientific. But I have one experience with this. I mean, uh, I don't have that much experience, but like any new revolution with all the crazy new ideas will ultimately lead to the same corruptions. And like you can see it in the French Revolution that basically I feel like John Block said this. Oh no. Basically the philosopher George Washington, yeah. So basically this guy George no please. Okay, so John Block, what philosopher inspired the American Revolution? John Locke, my bad. So basically, what this guy said about the French Revolution is that what the government is under the king is already too complex, but it's working. So should you make a revolution, get rid of it, and start everything from the bottom? Because that's gonna take like 100 years. Because it already took like hundreds of years to make France what France was. So now you want to just overthrow it. Probably his main point was that you should be just aware that it's gonna take a while to see like the fruits of the revolution and the new thing. So my first impression and assumption about this is that we gotta be patient with this. Where they are leading us, I mean, we are almost halfway, but and I feel like they have some good merits. I'm not saying they will not have any merits, but this will take time, definitely. And for the company itself, I feel like they should be patient. They should just keep making things better and better and better and better and never stop. And then at some point, it's just better to use it. It's like someone has like half of the cost of cloud with this or internet, then they should just use this new technology. But it's gonna take a while, in my opinion. Alright, so dominoes. If we fix the internet, a whole chain of dominoes can come falling down and we reach the next stage of technology evolution. If you want to know the bottleneck in any particular economic system, look for who gets to charge rent in the tech war. That's AWS. Sure, Apple's there selling popular laptops, but you could buy a different laptop or a different phone. And Microsoft was the gatekeeper for everything once, but you don't have my Windows locking anymore, unless you choose to. Although the web is the new operating system people of the early 2000s finally want. That includes Larry Ellison, I guess. We just forgot to celebrate. But the liberation didn't last long. If you deploy software, you probably pay rent on AWS. Why is that? Compute, right. AWS provides scalable computing resources. Well, you think so, but lots of people sell computing resources way cheaper. Even a mid-range MacBook can do 10 times or 100 times more transactions per second on its SSD than supposedly fast cloud local disk, because cloud providers sell that disk to 100 all the virtual machines to 100, 10 to 10 or 100 people at once while charging you full price. Why would you pay exorbitant fees instead of hosting your mission critical website? Why are they this on your super fast MacBook? We all know why. It's because you don't have a static IP address, I guess. IPv4. Location, developers, developer. You pay exorbitant rents to cloud providers for their computing power because your own computer isn't in the right place to be a decent server. It's behind a firewall and a NAT and a dynamic IP address and probably an asymmetric network link. So basically what a asymmetric network is, for those who don't know, when you have a network request, it comes from one route, but if you respond from the same route, then you have symmetric network. Now, if you get a request, but you choose another path for whatever reason, then you will have asymmetric network. So you can respond to the client from another network. That's what it means. Link that drops out just often enough to make you nervous. So basically this is what they mean. So because all the internet providers have to basically provide you with different levels of dynamic IP addresses and network address translations. So in your house you have a router, and then your house gets assigned a dynamic IP address from your internet provider. And then basically, yes, you can port forward and stuff like that, but it's way easier to just go on AWS, click two buttons, and then you already have an IP address. Alright, so you could fix the network link, you could reconfigure the firewall and port forward through the NAT, I guess. And if you're lucky, you could pay your ISP an exorbitant rate for a static IP and maybe get a redundant internet link. And I know some of my coworkers actually did do all that stuff on a rack in their garage, but it's a lot of work. It is a lot of work. I've never been able to do it because I don't have access to the router myself. But it's a lot of work. But it's probably one of the most fun hacky skills that you can have. But it's all a lot of work and requires expertise, and it's far away from building this stupid dashboard or blog or cat video website you wanted to build in the first place. It's so much easier to just pay a hosting provider who has all the IP addresses and network bandwidth money can buy. And then if you're going to pay someone and you're a serious company, you better buy it from someone serious, because now you have to host your stuff on their equipment, which means they have access to everything. So you need to trust them not to misuse that access. You know what? Nobody ever got fired for buying AWS. That's an IBM analogy. We used to say nobody ever got fired for buying IBM. I doubt that's true anymore. Why not? Alright. If you're going to pay someone and you're a serious company, you better buy it from someone serious, because now you have to host your stuff on their equipment, which means they have access to everything. So you need to trust them, not to misuse you. Basically, yeah, that's something I never understood with cloud providers. It's sure, you're not gonna touch it, but I don't trust you. And to this day, I don't think there's any other option for almost anyone unless you have your own on-premise data centers. It's easier, man, but it's all about the advantages and disadvantages you get. I don't know, maybe the business doesn't care about the client's data, or the data is not just that important, but can almost say that about everything. Oh yeah, medical reports. Sure, these are just, I don't know, but we can also say, yeah, it's these are like the smallest things are very very important. Like my password is like probably the same password for everything else. So if one website gets hacked, all the data can be very very harmful to everybody. So these guys are getting to somewhere nice. I like where this is going. Okay, pendulums. I refuse to say pendula. Okay. IBM mainframes still exist and they probably always will. But IBM used to be able to charge rent on every aspect of business computing, and now they can't. They started losing influence when Microsoft arrived, stealing fire from the gods of centralized computing and bringing it back to individuals using. Oh, well, thanks for giving no credit to Apple. Tiny underempowered PCs on every desk in every home running Microsoft software. I credit Microsoft with building the first widespread distributed computing systems, even though all the early networks were some variant of sneakernet. What is a sneakernet? Well, okay, I get it because these guys are focusing on the business side. I mean, probably makes sense. They are not made. Sneakernet is a term used to describe the method of transferring data between computers by physically moving storage devices such as floppy disk computer. Okay. Okay, yeah, just no cables, just storage disks or devices. Alright, I think we can argue that we are now in a post Microsoft Web First world. Neat. Is this world a centralized one like IBM or a distributed one like Microsoft? When I did this as a talk, I took a poll. It was 50-50. So bad news. The pendulum has swung back the other way. IBM was centralized, then Microsoft was distributed, and now the cloud plus phone world is centralized again. I mean, he's right with all the large language models. His argument is correct that we are going through another centralized phase that just upload everything to somebody else's laptop cloud and they do all the calculations for us and we will be happy. We've built a giant centralized computer system with a few mega providers in the middle and a bunch of dumb terminals on our desks and in our pockets. The dumb terminals, even our smartwatches, are all supercomputers by the thousands of 20 years ago. If you use them that way, but they are not much better than a VT100. Turn off AWS, they are all bricks. It's easy to fool everyone ourselves into thinking the overall system is distributed. Yes, we build fancy distributed consensus systems and our servers have multiple instances, but all that runs centrally on cloud providers. Facts. And this isn't new. IBM was doing multi-core computing and virtual machines back in the 1960s. It's the same thing over again now, just with 50 years of Moore's law on top. We still have a big monopoly that gets to charge everyone rent because they are the gatekeeper over the only thing that really matters: computing. Oh, connected operating systems. Sorry, just kidding. Connectivity. Everyone's attitude is still stuck in the 1990s when operating systems mattered. That's how Microsoft stole the fire from IBM and ruled the war. Because writing portable software was so hard that if you wanted to interconnect one program to another, if you wanted things to be compatible at all, you had to run them on the same computer, which meant you had to standardize the operating system, and that operating system was DOS and then Windows. The web undid that monopoly. Thanks, Paul Graham. Now JavaScript matters more than all the operating systems put together. There is a new element that controls whether two programs can talk to each other, HTTPS. If you can HTTPS from one thing to another thing, you can interconnect. If you can't, forget it. Okay. Certificates. And HTTPS is fundamentally a centralized system. It has a client and server, a dumb terminal, and a thing that does the work. The server has a static IP address, a DNS name, a TLS certificate, and an open port. A client has none of those things. A server can keep doing whatever it wants if all the clients go away, but if the server go away, a client does nothing. Alright. We didn't get here on purpose. Mostly it was just path dependence. We had security problems and IPv4 address shortage, so we added firewalls and nets. So connections became one way from client machines to server machines, and so there was no point putting certificates on clients. And nowadays there are 10 different reasons a client can't be a server, and everyone is used to it. So we design everything around it. Dumb terminal and centralized servers. Just it all makes sense. Basically, our devices, which are the clients, which are our personal devices mostly, and our PCs, laptops, iPhones, all that basically are in nets of nets of nets, and then all the configurations change. They are just not meant to be the server at the same time. They are not designed that way, and I feel like it gives it some benefit. Like, I'd say give it some benefit. I don't know why, but I feel like where these guys are getting at, it's basically saying give the same power to these guys over a new protocol that a device with any computation power can do both. We can have everyone serving and being client. Alright, tail drop. Okay, fast forward. We spent the last 5 years making Tailscale the solution to that problem. Every device gets a certificate. Every device gets an IP address and a DNS network. Okay, so I guess they're using 64-bit IP addresses to scale for everything, and a DNS name and end-to-end encryption and identity, and an identity, and safely bypass firewalls. Every device can be a peer, and we do it all without adding any latency or overhead. That's the new internet. We built it. It's the future. It's just unevenly distributed. So far, for people with Tailscale, we've already sliced out 10 layers of nonsense. Alright, so the revolution is here. They are getting rid of a lot of layers. That's why developers react so viscerally once they get it. Tailscale, right, I have to pronounce this right. Okay, let's see. Visceral. Oh, I was right. Alright. That's why developers react so viscerally once they get it. Tailscale makes the internet work how you thought the internet worked. Everyone having the same things as anyone else. If you want to be able to serve something, you should be. It's pretty good. Before you learn how the internet works, I'd like to use Taildrop as an example of what that makes possible. Taildrop is a little feature we spent a few months on back when we were tiny. We should spend more time polishing to make it even easier to use, but at its core, it's a demo app as long as you have Tailscale already. Tailscale is just one HTTP put operation. The sender makes an HTTP request to the receiver, says here's a file named X, and sends the file. That's it. It's the most obvious thing in the world. Why would you do it any other way? Alright, so these guys are working on it. Put operation, the sender makes an HTTP request to the receiver, says here's a file named X. That's it. It's the most obvious thing in the world. Not getting this exactly, but let's continue. Well, before Tailscale, you didn't have a choice. The receiver is another client device. not a server, so it was behind a firewall, with no open ports and no identity. Your only option was to upload the file to the cloud and then download it again, even if the sender and receiver are side by side on the same Wi-Fi. Ooh, interesting. But that means you pay cloud fees for network, egress and storage, and the CPU time for running whatever server program is managing all that stuff. And if you upload the file and nobody downloads it, you need a rule for when to delete it from storage. Also, you pay fees just in case to keep the server online, even when you are not using it at all. Also, cloud employees can theoretically access the files unless you encrypt it, but you can encrypt it without exchanging encryption keys somehow between the sender and recipient. And how does the receiver even know a file is there waiting to be received in the first place? Do we need a push notification system for every client perform? And so on. Layers and layers and layers of gunk. And all that gunk means rent to cloud providers. Transferring files, one of the first things people did on the internet for no extra charge. Via FTP now has to cost money because somebody has got to pay that rent. Well, now I'm wondering, character names of social network. Alright, so let's go to Sean Park here. There we go. What did this guy do? So he Napster. Okay. How did Napster work? Because this is referring to Napster. It's a peer-to-peer file sharing, primarily associated with digital audio file, founded by Sean Fanning and that guy. Platform originated. Okay, so let's go to data. Engineering of it. Was envisioned as an independent peer-to-peer sharing. The service operated between. Oh wow, they almost got it running for 2 years more. Its technology was put to easily share the MP3 files with other participants, although the original service was shut down by Quora. The Napster brand survived after the company's assets were liquidated. What kind of assets do these guys have? So peer-to-peer file sharing is the distribution and sharing of digital media using peer-to-peer networking technology. P2P file sharing allows users to access media files such as books, music, movies, and games using P2P software program that searches for other connected computers on a P2P network to locate the desired. The nodes of such networks are end-user computers and distribution service. There's So perhaps this is not that new, but this was shut down, and probably because it was shut down, the whole design is not considered to be legit anymore, because every time there's something like this, it's shut down by a court or an authority. So let's see what else these guys have to say about this. The early days of file sharing were done predominantly by client-server transfer from web pages. FTP IRC is a text-based chat system for instant messaging. Before Napster popularized a Windows application that allowed users to both upload and download with a freemium style service. Record companies and artists called for its shutdown. FBI raids followed. Napster had been incredibly popular at its peak, spawning grassroots movement following from the mixtape scene of the 80s, and left a significant gap in music availability with its followers. Right here. Peer-to-peer file sharing technology has evolved through several design stages, from the early networks like Nutella, which popularized the technology in several iterations that use various front ends such as Kazaa, LimeWire, VNMX before EdenCube. Okay. Then on to later models like BitTorrent. BitTorrent. A marketer uses it for update distribution and online video games use it as their content distribution network for downloading large amounts of data without incurring dramatic costs for bandwidth inherent when providing just a single source. Several factors contributed to the widespread adoption, facilitation of peer-to-peer file sharing. These include the increasing internet bandwidth, the widespread digitization of physical media, and the increasing capability of residential personal computers. Users are unable to transfer one or more files from one computer to another computer across the internet through various file transfer systems and other file sharing networks. Alright. So from what I'm concluding just from now is that this idea is obviously not new, but okay, so I'm a little bit hesitant to adopt to this new technology because the protocols are a way to govern the infrastructures, not the other way around. So if you pay for a cloud provider, that's because they give you a fiber optics cable and good internet speed and all that, and then you don't have to worry about anything else. Saying that, I don't think all pieces need to have the they don't want the capability to be a server, but it would be nice to have that option. Yes, I agree. But meanwhile, you're not changing the infrastructure. So like one of the reasons companies choose to have centralized systems is because the manager wants centralized access. So they want to have control over everything. So they don't want to just trust one computer. And that centrality gives them that option. But as he mentioned, Avery mentioned in this, if you're just having a blog, then yeah, probably this is better thing. I'm gonna read the comments after this, but just stay with me. Let's just finish this and then we can analyze. The new internet Teldrive is just an example, a trivial one, but it's an existence proof for a whole class of programs that can be 10 times easier just because Tailscale exists. The chain of dominoes starts with connectivity. Lack of connectivity is why we get centralization and lack of connectivity. Centralization is what we pay rent for every tiny little program we want to run, and why everything is so slow and tedious and complicated and hard to debug, like an IBM batch job. Alright, I need to know more about that. And we're about to start those dominoes falling. The glimpses at these possibilities why our users just get excited about Tailscale more than they've ever been excited about some VPN or proxies, because there's something underneath our kind of VPN that you can't get anywhere else. We are removing layers and layers and layers of complexity and making it easier to work on what you wanted to work on in the first place. Not everybody sees it yet, but they will. And when they do, they are going to be able to invent things we could never imagine in the old centralized world. Just like the Windows era of distributed computing made things possible that were unthinkable on a mainframe. But there's one catch. If you're going to untackle the hairball of connectivity, that connectivity has to apply to everyone. Okay, has to apply to everyone. There is going to be a new world of haves and have-nots. Where in 1970s you had or didn't have a mainframe. In 1995 you had or didn't have the internet. Today you have or don't have a TLS certificate. Tomorrow you'll have or not have Tailscale, and if you don't, you won't be able to run apps that only work in a post-Tailscale world. And if not enough people have Tailscale, nobody will build those apps. That's called a chicken and egg problem. This is why company strategy sounds so odd at first. It's why we spend so much effort giving Tailscale away for free, but also so much effort getting people to bring it to work. So much effort doing tangential enterprise features so executives can easily roll it out to whole Fortune 500 companies. The internet is for everyone. The internet is for everyone, you know. They were internet works lowercase because the internet capitalized. They all lost because the internet was the most diverse and inclusive of all. To the people building the internet, nothing mattered but getting everyone connected. Adaptation was slow at first, then fast, then really fast. Today, if I buy a wristwatch and it doesn't have an internet link, it's broke. We won't have built a new internet if nerds at home can't play with it, or nerds at universities, or players at enterprises, or eventually every person everywhere. There remain a lot of steps between here and there. Let's save those details for another time. Meanwhile, how are you doing? Well, about 20,000 people in the world uses the new internet. Oh, that's a lot. Let's say you have 8 billion people. 8 billion has 9 zeros. And then you divide it by 2 of 4. Remove 4 zeros. Alright. Tailscale have 500,000 users. I guess, yes, 500. Am I right? 400,000. Yep. 400,000 users. We are not going to stop until it's all of them. I'm old enough to remember when people made fun of Microsoft for their thing about putting a computer on every desk, or when TCP/IP was an optional add-on you had to buy from a third party. All that was less than 30 years ago. I'm old, but come to think of it, I'm not that old. The tech world changes fast and can change for the better. We're just getting started. Okay, so is this the last blog these guys have? This is the last blog they have. Okay. Alright, so let's go through some of the comments maybe. Alright, right off the bat, looks like a criticism. The internal problem with companies like Tailscale and Cloudflare, Google, is that by solving a problem with the modern internet, which the internet should have been designed to solve by itself, like simple end-to-end secure connectivity, Tailscale becomes incentivized to keep the problem. What the internet would need is something like IPv6 with automatic encryption via IP security with PKI, KI provided by DNS security, but Tailscale has every incentive to prevent such things to be widely and competitively implemented because it would destroy their business. Their whole business depends on the problem persisting. Interesting. I never thought of this forces me to rethink every negative post people made against DNS security, which shaped my opinion. I still think that IPv6 and DNS security do more harm in practice than what they solve. Maybe the SC Daily podcast can do a deep dive on this together with somebody who is militantly pro DNS security. An example, a form of pre-reserve incentive or the Cobra effect, endemic to capitalism, especially in infrastructure. Alright. So I'm not sure how these work, but 14 minutes ago. I'm one of the people who actually use Tailscale for production systems where there are servers physically close to me or at some other control location, and then there are hundreds of users hundreds kilometers away, all working via Tailscale. I should say two things. Tailscale is amazing and I love it. The system could not exist without it. And I had at least 10 more people in my team to manage all this 24/7. It's working and it's good enough. That being said, you don't need to lower your expectation. It's not as good as the internet. The latency spikes periodically. The connection drops sometimes. The magic DNS just magically stops working or interferes with the system. Since we have many users, we've encountered every possible problem one can encounter. And then there's still something new you'll see tomorrow. In any case, we believe in Tailscale and its vision. It's a categorically new approach that simultaneously gives you the control on hardware, reduces the cost, and improves the security. Our first big production server was a 4-core Linux laptop. We love Tailscale and we wish the product prosperous life and development. Thank you, team. Things like head scale, but the whole everyone gets an IP doesn't depend on this on a massive IP address. We can all wait until full IPv6 rollout, or we can depend centralized IPv4 on servers and priority stuff. Maybe a bit hypocritical. Oh, okay. So I'm assuming Tailscale allows you. I'm not sure what Tailscale is. I have some assumption, but I might not be correct. Okay. Aggrandizing. You have a mesh VPN product with some value-added services on top of it. That's great, but this idea isn't novel or unique. Why should your solution be the new internet instead of any of the alternatives? I wouldn't want to rely on a single company for all my internet infrastructure anyway, so I'll stick with the traditional internet with all its complexity. Its major problems aren't technical but social, and no new technology will solve those. Alright, I think this is good. This is a good wrap up, these two together. Okay, so basically this other person, Eddie and iMeric, they're going at it. Really, isn't the major problem of the current internet is inherent centralization of services, because the initial promise of 100% decentralized networks is simply too complex to realistically manage? I view that problem as deeply technical, unless if by social you simply mean everyone become an experienced sysadmin, or the slight variation of it. Everyone should know an experienced sysadmin who's willing to run their application for them for free. Take something as mainstream as social media. Imagine a world where Facebook, Twitter, TikTok, YouTube, Reddit, worked seamlessly like BitTorrent. An application on your machine, when you run it, it joins a Facebook network where your friends see you online through their instance of the application. Your feed, wall, etc. is served to them directly from your machine. All your communication with them is handled directly between the two. Excuse me. Or thousands or millions of you. No centralized server needed. You can easily extend and apply this majority of centralized application to them. And the only ones I can think of where this wouldn't work would be inherently centralized services like banking, for example. There are already plenty of P2P networks that show that this is a viable solution. Of course, blockchain and BitTorrent, SoulSeek, that's a new thing. All the problems you will run into, however, to make this as seamless as just connecting to Facebook.com are purely technical. The initial big hurdle is seamless P2P connectivity. This is without port forwarding, dynamic DNS, and required advanced networking, security, and other sysadmin knowledge from every user. Next would be problems like what happens when the node is offline. What happens to latency and load if you need to connect to thousands, hundreds of thousands, or millions of machines just to pull a feed? How is caching handled? How are updates, notifications pushed? How do nodes communicate when they are wildly out of date? Where's your data store? How do you handle discoverability, security, etc.? All deeply technical problems. Most are solvable, but you're gonna have to invest a significant amount of effort to solve them one by one to reach the same brain-dead simple experience as a centralized service. The Fediverse has been trying to solve just a small subset of these problems for over a decade now. Solutions still require highly capable sysadmin to give users a similar or only slightly worse experience than you Twitter. Okay. Alright, so seems like to conclude all of this is that this is not a new idea to have decentralized nodes and computers working together, but like it said, there needs to be, like from the blog, there needs to be a lot more connectivity and infrastructure and just better personal devices to do all of this. We need probably like iPhones to have like 10 terabytes of data and huge RAMs, and huge RAMs means bigger battery, and it's all technical. And even when we reach that point, we don't just rely on text, and we use some sort of meta universe that our then devices is not enough to handle those, and still we have the problem to have exponentially bigger computers for class and exponentially bigger personal devices. So I think that's a good conclusion, but it's alright, but in today's world you want something that just works. Like you care so much about your data that you and your friends or your community that wants to access it. Then other than that, I feel like those people who want this, they can have it, and those people who don't want it, they have centralized systems, and I won't say they're ignorant about it, but the cost to benefit ratio for them makes sense to use these centralized systems, and they're okay. They get through life day to day, no problem. And it's all about what the user wants at the end of the day.